Hi guys, Ms. Kramer here with review video for section 11.3.5, which is the special right triangles that we learned. It was that mini sheet that just had a front and a back. So let's get started with this. So this is our right angles with special properties. We learned about two. We have the 45, 45, 90, and then we have the 60, 30, 90. Now remember with this, we can use the Pythagorean theorem if we want, but using these tricks when we have these two types of triangles will save us time. So when you have a 45, 45, 90 degree triangle, both the legs are the same, and then the hypotenuse is the square root of 2 multiplied by one of the legs. Common mistake here is people put the square root of 3 because they're so used to doing 30, 60, 90. So 30, 60, 90 now, as easy as 1, 2 square roots of 3. So with this one, I think the common mistake people have is not knowing which side is the short leg and which side is the long leg. They just base it off of how it looks, but sometimes you can't go off by that. So the main thing to remember is 30, whichever leg is across from 30, that's the short leg. So in this case, this would be the short leg, so we'll call that X. The long leg would be X square roots of 3, and then the hypotenuse would be 2X. Remember, the hypotenuse is the longest side of a triangle. So it makes sense that we're multiplying it by 2 because that would make it the longest. The square root of 3 is about 1.71. So notice how that's less than 2. So if you ever forget what to do if you multiply the hypotenuse by 2, or is it the long leg, just think of that. The hypotenuse has to be the longest, so multiplying it by 2 will make it longer than the other sides. Alright, so let's try an example. So again, here's your 45, 45, 90 degree triangle. This is the theorem. Key thing to remember here, S square roots of 2 for the hypotenuse. So example 1, 45, 45 degree triangle. I know I can use my trick. One leg they already give me is 7, so that means the other leg must be 7. So the hypotenuse would be 7 square roots of 2. Notice how I did that in about 10 seconds. Using the Pythagorean theorem would take a little bit longer. Alright, where's our triangles? Oh, there they are. Okay, so let's look at this one first. Again, I see my labels for the 45, 45, 90, so therefore I know the legs are 3, and then the hypotenuse is 3 square roots of 2. Someone asked me if it doesn't say 45, 45, 90, or if it doesn't have 30, 60, can we just assume that we can apply these rules? And the answer is no. Even if you're given something like this, where you know it's a right triangle, the sides could, or the angles could be 5 and 85. So they have to be marked in order to apply these rules, unless the directions say assume the angles are 45, 45, 90, or 30, 60, 90. You just have to know which one. And now this one, notice how we are given the hypotenuse, so we have to work backwards. So here, if I know that I take the leg and I multiply it by the square root of 2, then that means that the leg must be 6. Check it, 6 times the square root of 2 gives me the hypotenuse. Another way you could approach it is 6 square roots of 2. Working backwards, you know you would divide that by 2. That leaves you with 6. Square roots of 2 cross off. You could also rationalize the denominator, which why don't we do that for extra practice since we did that in section 11.4. So let's just say we don't cross off the square roots of 2, even though you could and you should. We'll just multiply by the square root of 2, top and bottom, to rationalize. On the top, we get 6 square roots of 4, 2 times 2. Bottom, we get the square root of 4. So 6 times 2 divided by 2, 12 over 2, which is 6. But again, from the get-go, you can just cross off those square roots of 2. All right, 30, 60, 90. So again, I think the main thing people forget on this is to see where the angles are. The way I think about it is whenever you have a 30-degree angle, so something like this makes 30 degrees, this would be the segment that would connect the two parts of the angle. When you have a 60-degree triangle, it's a little bit bigger. Notice how long the segment is that connects there. And then if you have a 90-degree angle, that is the longest segment. So if you ever forget just think of the segment drawing, if that helps. 30, 60, 90. 1, 2 square roots of 3. Okay, so the example. So we know 30, we know 60, we know one of the legs. Which leg is this? Well, from the picture it's kind of hard to tell, but I see there's 30 over here. So this is the short leg. So if the short leg is 5, that means that the longer leg would be 5 square roots of 3, and then the hypotenuse is 2 times 5, so 10. All right, example 2. Here's our triangle here. So this time, what do we know? This time we know the hypotenuse. So to get the short leg, we know we would do 16 divided by 2, right? Because the short leg is 8 times 2. And then the long leg would be 8 square roots of 3. Not sure if you guys can see that. There we go. 8 square roots of 3. So, again, main thing is make sure you know what your legs are. Alright, and how about this hockey one? We've got the turtle versus Bowser and Mario. And I hope you see my pictures are Mario Lemieux. Mario Lemieux. Okay, so let's see, our short leg is 9. So that means our hypotenuse is 18. The long leg must be 9 square roots of 3. Alright, down here, somehow my right triangle symbol got moved. Okay, let's see here. There we go. Sometimes when I upload this to the program, everything gets moved around. So our short leg this time is here, and we know it's 2. So the hypotenuse then would be 4. And then my long leg would be 2 square roots of 3. And that's it. So again, I think this is one of the harder parts of this unit. So please be sure to ask if you have any questions on anything. I'm here to help. Thanks, guys. Hope these helped.